These are the 3.1 notes for PreCalc. We're starting a new unit today. This is about scatterplots. So scatterplots are just an arrangement of points representing all different sorts of things, and they are plotted on a graph. So you've got your three basic types of scatterplots. You have this first one, which is what we call linear, because again, they are generally in the shape of a line. The next one is what we call nonlinear. Nonlinear can be any other mathematical shape. So it might be a parabola. It might be an exponential graph. It might be an x cubed graph. Anything that we've graphed in the past could be considered a nonlinear. This was a quadratic. But again, it could be any type of mathematical shape. And then the last one, if you just have a random spattering of graphs, of dots, that one's called neither. All right, so as we look down at example number 1, see if you can classify each of these into the correct category: linear, nonlinear, or neither. The first one should be linear. Generally makes the shape of a line. Second one is neither. Those dots look very random. The third one is linear. There are fewer dots, so people tend to connect the dots, but that's not what we're doing here. We're just looking for generally what shape it makes, and those look pretty straight like a regular line. The last one is nonlinear. That would actually be an exponential graph. Something like 2 to the x power. For example 2, we are going to create a scatter plot, and then we're going to classify it. So this is just remembering how to graph your ordered pairs. This should be pretty simple. -6, -6. That would fall right there. -5, -3. -1, -2, 0, 2, 3, 3, and 5, 6. And then as far as the classification goes, that one would be considered a linear scatter plot, because again, generally they're making a shape of a line. It doesn't have to be a perfect line, and it doesn't have to be all in a directly straight line, just a general shape. On the back side, we have something called correlation, which is how sets of data relate to each other. So how the x's relate to the y's. And there's 3 types of correlation here. You've got this first one, which is positive. You can see in the graph that this is generally going up in that direction. And if you looked at what this graph is actually about, it's about calories burned during exercise. You've got the time across the bottom for your x's, and then your calories burned along your y-axis. So a good sentence to write for this one, if you needed to explain it: as time increases, the calories burned increases. As your time goes up, your calories go up, which makes sense. The more you work out, the more calories you burn. All right, you've got this middle one here, which is just siblings versus pets, how many siblings somebody has and how many pets they have. Those look like they have nothing to do with each other, so we say there is no correlation, so the correlation would be none. And you're not able to write a sentence for that because the amount of siblings does not affect how many pets you have. This third one is going to be a negative correlation. You can see how the dots are kind of going downward. And how you would write a sentence for this: as your weight increases, meaning the weight that you're lifting, then your repetitions will decrease. As your weight increases, the heavier weights you lift, the fewer repetitions of that movement you're going to be able to do. So as one goes up, the other one goes down, as opposed to the positive, where as one goes up, the other one also goes up. All right, the last thing for today is what we call correlation strength. How close these dots are together. So you have this first one, which is no correlation. We say none. And then notice kind of on the second one, they start to form a little bit more. They start to look more like a line here. This one is still going to be considered weak. You can tell it's starting to form into something, but they're pretty scattered. The next one here, they start to line up a little bit better. We call that one strong. And then the last one, when they're lined up perfectly, we call that a perfect correlation.